All right, more statistics. So we've talked about how to group data. So moving on from there, we want to talk about sort of a way to summarize the data if you want to go through the various like bullet points of descriptive statistics. The big question we want to answer in this instance is, suppose we're given a data set. What would you call typical for the data set, or normal, or standard, of that kind of thing? There's one sort of glaringly obvious answer that I'll generally end up getting when I talk about this. There are a couple of others that I want to investigate as well, which also tend to turn up, especially if someone's already talked about statistics before they get into my class. Anyway, this idea of trying to figure out what's typical for a data set is talking about a measure of center or a measure of central tendency. So, and I intentionally avoided using one word in particular here when it comes to talking about measures of center in this instance. Instead of typical or normal or whatever, I avoided saying average because that's, generally the first thing that pops into somebody's head. Like if I ask how a typical student did on a math test, that's the kind of thing, it's like, well, did you calculate the class average kind of thing? And that is a very popular measure of center, and it's one we'll use a lot. So you'll notice statisticians refer to these things using words that all start with the letter M, so hopefully that'll help you remember this. You could talk about the mean of a data set. That is that numerical average. Hopefully I don't need to belabor the point too much on how we calculate that. You take all your values, you add them up, you divide by however many you have. So yeah. Generally speaking, if there's one thing I can rely on my Math 107 students to be able to do before they get into my class, averaging a set of numbers is pretty high up on the list of things I can count on. The other two generally come up, in some sense of if I were just sort of to, prod you like, Socratic questioning style about how you might determine what's typical, the average comes up generally at the top of the list. Next, somebody might end up talking about what we're going to call the mode of the data set. I'll go ahead and fill in the blanks. I mean, you're looking at the PowerPoint slides that have all these things listed anyway, right? The mode is usually the next thing people might mention, because it's the idea of what shows up most often in your data set. So if you were thinking about this in terms of what we talked about in the last section with grouping data, if you have individual values, it's the one with the highest frequency. The median of people kind of get the idea, but it's probably the trickiest to describe, because when you think of median, at least when I think of median, I think of that little divider in the middle of the road. So yeah, that's really what you're dealing with here. You need the middle of your data set, but you have to make sure your data are sorted first. High to low or low to high doesn't really matter. So it really is kind of a measure of center. It's like in the middle of the data set. So all right, so we got the middle of the data once we've got them sorted. So that's that. So those are our three measures of center. There's technically one more you'll hear some books talk about called the mid-range. We don't worry about mid-range. Don't worry about it. All right, so we've got these three guys here. What do they look like in the context of an example? I tried to pause and failed. The frustration of tapping my touchpad and having moved off the pause button is annoying me, but no matter. So I gave you an example in the slides. These are actual test scores I had for one of my upper level math classes from years ago. I obviously haven't attached students' names to them or anything. But anyway, so this was how students did on their first test in a calculus class of some sort. Okay. So if we wanted to figure out how the class did, we can work out the various measures of center that go along with this. So we could have our mean, we could have our median, and we could have our mode. All right. The mode is probably the easiest one to deal with. I've already done you the solid of sorting the data from low to high. Only one data value shows up more than once here, right? We've got a pair of 86 scores, so that's our mode. The mean, like I said, that's usually, instead of asking about the class average, that's just about always the first thing that pops up when students ask me about how people did on the test. What's the class average? So if we work that out here, adding up those numbers, I got 662, and there are 8 scores there, so I need to divide that guy by 8. That would give me a mean of 82.75. So a little lower than the mode, but if you were asking how the class did on average, that's still like a B, so that's pretty good, right? The median can be a little bit tricky to talk about, and the median can be kind of weird because how you calculate the median can differ a bit depending on how many data values your set has. So this one's got 8 values. So technically, like, the middle falls right between those two guys. For this data set, it's not too big a deal. In general, if you have that happen with an even number of values like we've got here, you need to calculate the mean or the average of the two guys in the center. So this time around, though, they're both 86, and averaging a pair of 86s still gives us a median of 86. If we had an odd number of data values, like there was another score up here, or like somebody got 100 or something, then there really is just a single value in the middle, and that one central value is your median. We'll play around with this example in a moment, but hopefully that's relatively straightforward now. So if you were trying to get a feeling for how the class did on the whole, I mean, they're not necessarily in 100% agreement, but they all kind of say the class did pretty well. These are all solidly in the B range, right? So now, I mentioned that the median is kind of weird, because how you get it depends on whether you've got an odd or an even number of data values. The mode kind of has some weirdness built into it as well, because you might have ended up wondering at this point, well, what would have happened if somebody else had gotten like a 98? So we had like a pair of 98s, or the 74 and the 78 were matched up. If it turns out there's a tie for the most frequently occurring data value, your data set actually has multiple modes. If it's like a pair of 98s, you'd say the data set is bimodal. You could technically, although it's leaning into being pretty rare, have 3 modes or more. So the mode can be weird like that, and you may end up wondering, well, what if there's a complete tie and like no data value actually repeats? Every number is distinct in your data set. Then it turns out your data set doesn't have a mode at all. So yeah, like I said, the mode can be kind of quirky, which ends up making, well, why do we worry about all of these? Why don't we just always use the mean? I mean, for what it's worth, once we leave the section behind, the mean is like a one measure center we're going to keep coming back to over and over again. It turns out there are times you can't really use a mean. Like, what if your data values are not numbers, or like if you were getting like yes, no, or voter preferences or something like that, where the answers aren't numbers. It doesn't make sense to average a bunch of people's names, really. Even if the data are numerical, it might not make sense to average them. The example I like to use in my classes is, what if I gathered up the area codes of everybody's cell phones in my class? I mean, sure, they're numbers, but what does averaging the area codes tell me? Not a lot, as far as I'm aware. So in that instance, talking about a mode makes more sense then. So that's kind of an idea as to why you might want to use one of these. I've got another, kind of example, piggybacking off these test scores. So I usually describe this in class. Somebody's come in, they need to graduate. Professor Carroll, I need to take this class in order to graduate this semester. Well, we've already taken our first test. It's highly unusual to let somebody add a class at this point. I know, but I promise I'll get caught up. And they, entreat with me for a long time about this. It's very emotional. And in a moment of weakness, I let them add the class. It's like, well, you're going to need to take the test. Sure, I'll get notes from somebody. So they go through this whole spiel. They end up taking the first test. So now I've got another test score to add here. And if you look at the slides, oops. So yeah, they didn't do so well. In case anybody's worried, no, this didn't actually happen. It's completely hypothetical. Nobody added my class really late, needing it to graduate, and then did this poorly on test 1. Just hypothetical. Okay. So now it is a valid data score, though, so now I've got to include it when I change, as you're going to look at these measures at center. Now the good news is, well, it hasn't affected the mode, right? Because there's not multiple 12s. So the mode's still 86. It was the only thing that repeated. If we look at the median, well, now I have 9 scores instead of 8. Well, if I count down, there is exactly one number in the middle now. And it's this guy right here. There's 4 numbers above it, 4 numbers below it. 86 is still our median. What happens to our mean, though? Well, that's kind of the issue. So if we add up the numbers, we should get a total of 674. Now I've got to divide by 9. and that changes the mean a bit. So let's see, I got 74.89. So according to median in the mode, the class still did pretty well overall. The mean, it may not be a cause for emergency, but if all I did was calculate the class average, I've gone from a class average of B to an average like in the center of the C zone, which might be a little more alarming. So that's kind of the issue where means end up having a bit of a problem here, because it turns out of these three measures of center, the mean is the one that is most sensitive to weird edge cases like this. So this is an example of what you might call an outlier for a data set, a data value that's really far removed from the bulk of the data. Like if you were to plot these things out on a number line, this 12 is way far away from the others, right? And the mean is prone to getting skewed by outlier data values. Like in this instance, the class average dropped by like 8 points because one person did really badly on the test. But this average doesn't really tell the full story here because, I mean, let's face it, only 3 people did worse than that mean that's showing up, and one of them is like right there. I mean, it's not really an accurate picture. So data sets that are prone to having outliers in them are frequently, you'll hear things cited using medians instead. Things like, salary data or home values, things where you might have somebody who's drastically overimproved their property, or you have a handful of people who are way wealthier or way, less fortunate economically than everybody around them. That's why you might want to, refrain from using a mean if it turns out your data can kind of skew, because of a value or two that's way removed from where everybody else is. So that's our measures of center. Like I said, I kind of just said why means aren't the end-all be-all, but then we're basically going to focus on dealing with means for kind of the rest of the chapter. I'm going to take a look at something else related to mean calculation in our next video, so stay tuned.